Okay, we're here at Wilson Audio Specialties factory, and I did not bring my my high-definition camera, so we're going to have to use the phone. I thought it was going to be a listening session, and that's fine.
So milling composites. As you've seen this big 2-bed, 7-ton machine, 5-axis, 2 beds, 2 heads. What they're doing with that is they're staging one mill job while the other job is being completed. X material is very difficult to machine because unlike aluminum, it retains heat. It's an insulator, and so all that heat goes back up into the machine head and burns up the tool. And so they typically change tools 3 times a week until quickly they burn out.
And what parts of these are looking at?
These are the whooper baffles for the event.
Oh, cool.
This is all the parts that go into the event right here.
The event.
These are all the machine tools that are staged to be sharpened. And so they'll take the bit out and they'll resharpen it. It can be reused twice. Same here. And you can see the dark area here. This is the area that gets worn, and then they resharpen that. They can do that twice, and then they have to. These are about $380 a piece. Pallets.
What panel is that? Because I can't.
Side panel for the woofer.
Oh, I see. And what are all these grooves in the inside? What are the grooves on the inside for?
Grooves are for the matrix brace.
I see.
Each of the cabinets cure for 3 days. This is a humidity and heat control room. It's about 130 degrees here. All cabinets cure for 3 days.
Is that an Alex or a XLR?
Alexander.
Alexander, yes, I thought it was.
Types of materials. This is the S material, which is also a composite, but it's made exclusively for the mid-range driver. So anytime you see a mid-range baffle, it's going to be this S material. S because it was first developed for the Sasha. The rest of the cabinets are typically X material, which is another. Let's look here. These are that's. These are. Sasha Series 2s. Alexia's lined up here on the right. Alex. Again, you can see anywhere there's a mid-range baffle is going to be that S material.
Right.
Here you can see where the grooves are for. It's that matrix brace. This is the sanding area. They use calibrated sanders rather than belt sanders. You can see this this piece of steel on top here. It's a calibrated piece of steel. It's calibrated within 0.004 of an inch.
Wow.
And it's, you can see a huge one here that they use. They use calibrated stainless sanders for the finish work because the tolerance at that point in the end finished cabinet is 8/1000ths of an inch for flatness.
Wow.
That's right.
So when
Clint Odom, he was our gel coder, and we always like to ask these guys how long they've been here. So Clint, how long have you been here? Clint, how long have you been here?
20 years.
20 years.
You started when you were 7.
I'm aging well.
Yeah.
So they're sanded. They've been passed on that tolerance of 8/1000ths of an inch, and then they're gel coated. This is a foolproof gel coating.
27.
Gel coating is the same process they apply to boats to make them seaworthy. They apply it over the composite, the fiberglass. It seals, makes that composites paintable for one. It also seals it from the elements. And this, you can see that it's a very dirty process. It's a thick coat.
And so that's not painted yet? That's not painted?
It's gel coated. So these are, let's give you an idea here. This is the shell that's applied to that.
Wait, now what's that? That looks like it's wood. What is it?
No, it's just that's just tape.
Oh,
So they don't
okay.
paint that surface
I
because they
people
want
to know
that.
it's not wood. It looks like it's wood.
It's paint.
Okay.
It's tape. So if I take that off, that's
Okay,
yeah.
I trust you. I believe you.
so it's quite a thick shell. You
Yeah,
apply to that,
Gel, yeah.
and protects the composite from the elements, but it also provides a consistent substrate on which to paint. So that rather than have all these differentiated joints and materials, it's a smooth shell that you can paint. So that's done. It also dries for 3 days down here on the shelves. And then it's sanded in here. Here you can see these 3 silver machines. Those are big air handlers.
Right.
Very dirty process, and they want to keep this isolated. So
Right.
they recirculate the air in this room about every 3 minutes.
It's like an automotive paint shop.
Right.
Or like a factory.
Sanding process. What he's doing here is applying a coat of black sanding material so that he can see where the irregularities are in the surface as he sands
Sand
it.
it down.
Yeah. And so if you can see a black spot, he knows that there's a dip there.
Yep.
And you see these lifts enable them to put the product up there safely so they're not lifting it clear up on these tables.
Right.
And so this process, this is before it's been sanded in that room.
Right. Oh, it's just after the gel. Sure.
Just after the gel's rough. And so
Yeah.
the tolerance here is 4/1000ths of an inch. So when they put the shell on, it's 8/1000 before, and then after they send it to a 4/1000ths of an inch tolerance for flatness. Once it's been inspected, it comes out, and feel the difference here for that.
Oh
Smells
wow.
like glass.
Yeah, it does. But this is just still a gel coat.
Yeah,
Yeah.
still the gel coat. So very, very smooth and very hard. It's a polyester-based shell, identical to what they use on boats. This is Brian Tran,
Hi
he's our
there.
master painter.
Right.
Brian, how long have you been here?
About 19, almost 20 years.
Wow.
These guys, it's a guild culture. These guys, Dave has done an excellent job of building a culture of craftsmen that have honed their craft for decades, literally. And he's
Yep.
found a way to keep them health insurance, great salaries.
These are
Alex's.
Alex's waiting to be painted, so they've all been.
They've all been
Gel
sanded
coated
again.
and
You can
sanded.
feel that surface.
Yeah. What's happening here? These are drying.
This is the curing area. You can see these are the vets. You can see Brian Schramm, this guy that we just talked to,
So the name is just.
and then the date.
Yep.
And by, these are almost ready to be sanded at this point because they're about 5 days into their curing process. And so
these have been painted and then they get
Painted.
sanded again.
then they get sanded again. So you can see that even now, though, you can see that the finish is starting to look pretty good here.
Yeah.
But not quite there. You can see a teeny bit of orange peel left if you look closely. Then I'll be gone.
I can't see it in this light, but I take your word for it.
This is typical painted process, wet sanding process. So feel the very, very fine, almost no grit.
Yeah, exactly.
So this is the last stage of the polishing process. So they get all that orange peel out of this, and then they polish it just as they would. Oh yeah, that's great. Earlier on, right? This is an earlier on process. Yeah. This is where they get that orange peel out. Is that correct? And then this is one of the later stages where they polish them. So after you do this, you clean it off and it's done. So this is the paint inspection area. You can see all these lights. They're all daylight temperature lights.
Right.
Lots of lumens. And Joe Allen is the same guy that's inspected all the cabinets thus far. So he's inspected the flatness for the sanding, the gel coat stage, and now he's going to inspect it for the paint stage.
And then he sees little
you
things,
can see,
little tiny
look,
things.
if you can find those, you'll be...
Yeah, little dimple. Yeah.
What's interesting is that you and I, if we were just looking at that surface from a normal distance, we would see it.
Yeah, but I think a customer, when they buy something like this, they're going to go over it. They're gonna...
It's viewed at, unlike a car, it's viewed at closer distances.
Yeah.
Indoor light, there's no,
Which reminds me of the joke about the lady goes into the butcher and she says, "Let me see that chicken." She picks the chicken up, she smells the front, she smells the back, she smells the top, she smells the bottom. She hands the chicken back to the butcher. She goes, "This chicken stinks." The butcher goes, "Lady, could you pass a test like that?" Okay, put it Okay.
These have all passed.
And then everything gets potted.
Yeah, once the crossover has been finished, and it's tested before it's
Right.
potted. Either accept or reject, and they pot it. And the potting provides a consistent mechanical and thermal substrate.
Right.
It makes it enormously
Heavy.
part of Dave's recipe for dynamic contrast is to overbuild the crossover so it doesn't saturate till well after normal use.
Right.
I mean, you could literally plug these crossovers into wall current and they pass this thing. Of course, they destroy the drivers if they're any connect.
Right.
These are Vette crossovers that are wired, and so every crossover, every driver, and every loudspeaker has a custom designed cable for that driver in that loudspeaker, which is different than let's say the tweeter from the mid-range, but not only the tweeter from the mid-range, but also the tweeter from the Sasha Series 2 tweeter. So it's custom designed to be a part of that crossover.
Wow.
And every
And you got to keep tabs on all.
Yeah, let me show you that.
I know these are soldered in place once
These are soldered.
once they're screw terminaled, they're soldered.
Mm-hmm. It's a gold plug there that they. So here's the recipe, if you will, for each of those.
Wow.
So Joe and Ben have been here for, okay, so Ben 17?
Yeah, 17 years.
And Joe 18 years.
Wow.
Joe's the production supervisor, so supervises all the build. Before they actually build the product up, this is still the empty shell, they frisk it so that as they handle the speaker, they don't damage the paint.
Right. That makes sense.
And really, applying this protective coating has become an art form in and of itself because they have to cut its shape and.
Yeah.
Yeah.
It's a shame it has to be peeled off when you're done. You know, when it gets to someone's house.
That's right.
So how many people work at this factory?
47.
How many?
47.
47. I think.
Thanks, Bills. That's okay.
And this is for the duet.
No, this is Alexia.
Alexia. Okay.
So you can see the woofers on the bottom and the woofer
Oh, I
crossovers.
didn't see that part of it.
Yeah.
That's why.
So, bottom crossover, top crossover. This is the one that sits behind the cover plate. And the drivers are matched vertically. So each mid-range is matched to its mating mid-range, which is in turn matched to the woofers, and horizontally. So the tweeters are matched together and so forth. And we catalog every speaker we've ever made. So if you had a Wapapi 3.2 that was purchased in '87, we would be able to build you a new tweeter replacement that would match that. Yeah.
That's important. That is really important.
These are mid-range drivers that are waiting to go on the bench to be broken in. They're broken in for 24 hours before they're tested. You can see the tweeters that are already breaking in. These are pre-manufactured. These are we actually after this test is done, we finish the tweeter after the products. We add magnets in a back structure so that it looks at the end. It looks like this.
Right.
It's okay. This is a anechoic chamber with a calibrated mic.
Huh.
And this one's set up for tweeter, as you can see. So they drop that tweeter inside there. They clamp it down. And if you look down the side there, you'll see the calibrated mic.
Yep.
That's how they test and match all the drivers to one another.
And these may look similar or identical on the outside, many of these silk dome tweeters, but they're different for each one.
So, for example, you can see 3 different versions of that. That's an old one. You can see 3 different versions of that tweeter. You have a white. You saw the blue out here.
And what's different other than the color?
The magnetic flux in the back, how they absorb the back wave, is completely different. There's 2 other versions of this tweeters, a black and a red, beyond. So people always ask us, why don't you use beryllium? This is a prototype of a beryllium tweeter. You can see this is a product that we developed in-house with, and this was actually, Dave, because of the two-way mid-range. One of the disadvantages of beryllium, and it doesn't have very low extension in the bottom part of its bandwidth. So really, in terms of most of our designs, it just simply can't be used.
Yeah.
But with the two-way mid-range, it allowed that, and so we were pretty far down the road, developing a bespoke composite beryllium tweeter. About a year of development went into that, and then we ultimately compared it after the end of its development to the
silk dome.
Yeah, this is an earlier version, earlier still, very late version. This is another diamond tweeter we were testing for that same purpose. This is a 3D printed baffle for that, so that it can go directly into the design.
Wow. So some of these look familiar.
Some of these look familiar. Early beryllium prototypes, original titanium driver. This is to give you an idea, this is the Revelator, which some people say is our driver, but you can see very clearly that it's quite different from different size baffle, different, it's a different driver than another diamond tweeter we're developing, diamond. You had another diamond tweeter somewhere here. So we've developed lots of different drivers with lots of different materials in the development process of doing the convergent synergy tweeter, and arrived at this through both testing, experimentation, of course, most important, listening.
And listening.
Same for all types of drivers. So materials testing. This is Vern Cordell. He's actually the acoustic.
Hi there. How are you?
Nice to meet you.
He's sort of a threefer. He is an acoustic engineer, an electrical engineer, and also has a degree in math. Am I correct in that? Math as well. So he's the one that actually did the original math, so that we were able to do the nomographs. So the tables calculating the distances. That is Vern's original. Developed.
You look through those numbers. It's
how did he come up with that math? Is the trigonometry really? Isn't
trigonometry and geometry. Mainly.
Yeah, right. And again, we always ask. And Vern's been here for 23 years.
Yeah. 24 actually.
24. His first project was the Grand Slam. working with Dave on the Grand Slam. And of course, that's the first speaker that had the chart, had the nomograph.
Yeah.
This is a laser vibrometer.
Correct.
Meaning that it shoots a laser out onto this material. So this is at the stage where we're saying, okay, this is an interesting material. Let's test the characteristics of this material.
So you're always looking at new materials.
Behind you here.
And these are materials that developed by companies that specialize in this. Or
Sometimes
Some of it. A lot of what we do is we start with one of their base materials and play with it.
Composite manufacturer.
Right.
And then say, let's make this change to it. Let's make a different modification to it. Well, this is an example of one that we were playing with. Let's see if I can find.
So your job is, let's face it, your job is to come here and play. Okay, that's
exactly
what you do. Okay.
Yeah, play. That's what makes the world go around.
That's right. Playing is good.
In there.
Yep.
So this is a composite with 6061 or some high grade of aluminum sheets that are interspersed in the composite.
And then you test it on that jig over there and see.
And this material is a new material that we've developed for the WAMM, but also appears in a small portion of the ALEX as well, where the upper array meets the gantry, the ladder support system.
Right.
The interface to that support system is this W material, which has the best combination of rigidity and damping of any of the materials we've tested yet. So it's an energy sink, if you will, right. So that it doesn't allow energy to get back up into the driver mechanism, but it also, any vibration that's generated by the driver is properly damped into this.
Drained out.
Yeah. Right.
Go ahead. What I've got set up here is our basic test setup of a material. So the laser is shining on the material. We've got the material in a jig configuration which would approximate a free space, so the material can actually warp, rotate, vibrate in as many dimensions as possible, and we only tie it down by just the points of the spikes. We also have the ability to clamp it.
Yeah, I see.
So that we can approximate if it were in an enclosure type, but this gives us basic raw information. Now I have a force hammer that's got an accelerometer built into it, as well as information from that's sent back to our control unit, and then it's all captured on this device. So I'll show you a basic test that we do.
Yeah.
So let's go. So I'll take 5 seconds worth of a measurement, which then looks like this. So we actually see that John did a double hit. Down here in the bottom, the accelerometer said that you went ta-ta.
Right.
And we try to just do a single hit.
So
but
again?
No, this is fine. I did a single hit before. So this is now showing the energy that the laser was able to pick up. And so there's our
the bottom is the hammer.
The bottom is the hammer.
Right.
And the top is what the laser saw.
And that's how quickly it settles down.
Mm-hmm. So this material, I took a measurement earlier, and I'll show you here's the 2 tracks again. Here's the material that I did the test with. So from that, taking this first channel, so just the return information, and then doing an FFT of that, we can see where its main vibrational information shows up right there at about
900 or 700.
That's just over 7,000.
7,000. Okay. I'm mathlexic, so that zeros don't mean anything to me.
Right.
Yeah.
One of the things that we wind up doing is out of this, I didn't have a standard analysis package out there, so I had to design through a MATLAB clone, Octave, a analysis package that gave a true waterfall style. So we've got delay in seconds, and then the frequency, and then a relative response. And so this was an early on one. I've since refined this many times. There's much more refinement. So looking at it in a 3D view versus looking at it as a top-down, So that's the top-down view if you were to look straight
This is
down.
a two-dimensional view,
Right,
a three-dimensional view. And as to reiterate, Vern wrote the software to, and as not only the software for this analysis, but also the crossover analysis software that we use in-house is an evolution of Vern's code, as well as the driver analysis. And
So what this is showing a
Flexure.
yes, the panel side. It's exaggerated.
I hope so. Otherwise, I think you should go work for a mattress company.
That's
Exactly.
right.
But
Remembering
that's-
that they're measuring billionths of an inch there.
Right.
They're measuring.
I got you.
So we're actually looking at, in this particular frequency, which is 280, 68 or 8, I can't see it from here. And so we get to see this particular panel
Mid-range.
clamped, how it's flexing in
Yeah.
relation to that frequency of excitement.
So this is where the first half of development's done in this room. Typically, it's either brought into this next room or up to Dave's listening room, depending on the project.
Yeah.
If it's a big speaker, we'll bring it up to Dave's room.
Right.
Smaller speaker, we develop it in this room, which is our 2-channel room. And it is also completely adjustable, but this is really designed to be a typical environmental.
Yeah, I think it's a nice size, big room.
It's a nice size. We could put everything up to Alex in here.
Yeah. Now, why are these particular?
These help us reposition without having to measure, and so we leave this material here. We've voiced and vowed this room.
Why are these particular speakers in here now?
Just because, just no particular reason.
Yeah.
And then even these panels are movable,
Slidable,
and adjustable.
yeah.
And if you look on the bottom here, you can see that we've calibrated that, so it's easy to do, repeatable.
Yeah.
So that if we put an Alex in here, it wants a little bit higher. The array is taller, and
Yeah.
therefore the adjustment of the room is different.
Yep.
And so this is the array. This is set up for the Sasha array, and as I say, much of the latter part of the development is done in this room,
Yeah.
or at Dave's.
Right.
Dave and Grill. This is actually my studio in the museum where we keep a bunch of the stuff. So where I shoot
Yeah.
the original Sasha. You can see the evolution
Yeah.
of that. Seven, blue. 6 in the red.
Right.
Wapapis both. Original Wit. Original Sophia.
What is that one there?
Wit.
I don't think I ever knew that speaker.
Yeah, Wit. This is a product in the early 90s. Original Grand Slam. Where is that? Oh, that was back there, wasn't it?
Yeah.
And the Series 2 Alexandria's and the XL off to the right of it. Max Series 2.
Oh no.
XS subwoofer. Thor's Hammer to the right. Original WOW subwoofer, which was a product made for the Wapepi subwoofer. And this is a Mezzo and Polaris center.
Yikes.
Original center. It's original, that's the current center to the right. That's the Grand Slam, of course. X1 Grand Slam. X is for what the composite's named after, X material. Although X material is in its 4th iteration.
Yeah.
It's not really very much like what was used in the original Grand Slam. It's not even the same.
So what year is that
manufacturer.
original Grand Slam?
That would be the late 80s, early 90s, 91 range.